conditioning, or does that mean we can roll down the windows, or we could turn on the vents and actually expect fresh air to come in? Once we've figured out that that means air conditioning, then as engineers, when we build that air conditioning, we can create tests which prove that our air conditioning is working correctly. Our customer doesn't necessarily understand any of this, but that's okay, he doesn't have to. What he wants is a good air conditioning. So basically, when we're delivering features, we need to start with acceptance tests. What are the acceptance tests which are going to make the customer happy? From those acceptance tests, we want to make sure that the code that we write to meet those tests that also works properly, and not just at the absolute top level, but all the way down. So what are we looking at? We're looking at, this is stuff for you to do research on, behavior-driven design, test-driven design at kind of the top level, getting into test-driven development and unit testing at the very lowest levels to ensure that when you deliver air conditioning, that this air conditioning is also going to work in the summertime. It's also going to work, when you take it down to the south where it's 10 degrees warmer than it is here, and the customer is still going to be comfortable in his car. So, we've said the objective of an Agile software project is to develop running tested features. Let's look at how a classically managed, a phase-driven approach would work. Okay? When we start out, we collect our requirements. Okay? You probably can't even see them, they're so far down. There's this little arrow down here that says requirements. How many running tested features have we produced after we finished our requirements?
0.
0, correct. Okay, so let's go on to the analysis phase. Any running tested features there? No? Design? Okay, now it gets tricky. Coding? Any running tested features there? Well, it depends. If you have a quality control group afterwards, they're going to start testing the code. They probably consider themselves the last defense against purgatory. Okay, and this is what happens. They start to test, and then you start to realize, well, first of all, you discover all of the things that have changed in the specification since you started work, since the customer wrote the spec. Because, of course, the customer has been talking to development, but not talking to test. So you actually spend a fair amount of time just trying to figure out what should we really be testing. And then you discover what doesn't work. And so you discover that a very small percentage of the features which you had originally developed are actually in the state running and testing. And when we say, I heard someone trying to describe the classical approach as robust project management. And I look at this graph and I say, how can you call this robust? Okay, because it is completely unpredictable when your software is going to be finished. Okay, so let's take a look at the Agile approach. Basically, in the first sprint, you deliver a couple features. They don't have a lot of business value. I mean, they're probably more like hello world stories, trying to, get the screen up or get the first interfaces going at the back end or whatever it is you're trying to do. But basically, with each sprint, you deliver more and more running tested features. And because you're using automated test methods, both to verify your acceptance tests and your internal quality controls, all those features which you developed in the first sprint, which were running and tested, after the third sprint, they're still running and tested, okay? And you get all the way to the end of the project, and they're still running and tested. What does this do? Well, it makes your development effort extremely predictable. It's possible to measure your velocity. And all of a sudden, once your velocity is known, then all you have to do is know how far away the destination is, and then you know when you're going to get there. Well, let's see. Bergamo to Milano is how far? 100 kilometers, 120 kilometers, something like that? Close enough? Let's just say it's 100 kilometers and my car does 100 kilometers an hour. So it's going to take me an hour to get there, assuming there's no traffic. If I discover that there's traffic and I'm only doing 50 kilometers an hour, well, gee, it's going to take 2 hours to get there. This has a very interesting side effect. This gives management control over when you arrive. Because they pick not only, they can't really directly influence the speed, but they can influence the distance. And so basically, if they say, we need to arrive by January 1st, and you know that we can deliver 15 features per month. Well, it's a month and a half, 15 features, so probably they can have 22 features. And if they ask for 30, you can tell them you're not going to get them. And so which 22 would you like? And so now we've introduced the concept of prioritizing. Okay, and so what do? Which features do we do first? Well, the must-haves. Real simple. The first thing you do is you get the system in a state where it's working, where it fulfills the minimal requirements that you set on it, and then you start adding luxuries. Okay, and then you add even more luxurious stuff. And finally, but by the time you're getting to the nice-to-haves, you realize that the nice-to-haves cost much more than they're worth, and so you don't develop them. Actually, probably, if you looked at a real project, somewhere in the middle of the shoulds, if the guy's done his priorities properly, somewhere in the middle of the shoulds, he's realized we have everything that we need for the customer to be happy with the system. Let's push it out and start working on the next version, which will bring more value. So, talking about execution, I'd like to now go back, take a step backwards, and think a bit about, well, how did we plan the project? I'd like to look at some of the prerequisites, some of the techniques you can use to do the planning, and then maybe try to put that together into a step-by-step plan, how you actually do the project. I said at the beginning, a fixed-price project is about managing risk. What that means is it's possible that the customer comes to you with a project where the risk is simply too high. Okay, and that means being able to say no. That means being able to have a clear concept. What are the red lights? What does it mean for us to say this project is not feasible? For me, one of the issues is if I don't think I can work well with a customer. If I don't trust this guy, or if I don't think he trusts me, and I don't think I can win his trust, that for me is a sign I should not be doing this project, because if we're going to spend the whole time distrusting each other, controlling each other, and fighting with each other, no. In German, they have an expression, better to end in a disaster than a disaster without end, and it's better not even to start the disaster. So, yes, have a clear-cut understanding of when you're going to say no. That also makes it much easier for you to negotiate. Because when your line has been crossed, you say no, and that's it, and the customer will accept that, and maybe he'll change his tactic. Or, as I say, you'll avoid this disaster without end. So, what can you do to improve your odds? What can you do to improve your odds of having a successful project? Well, lots of things. Starting with the planning, getting good estimates. That means getting your team involved very, very early. Getting good priorities set so that the stuff that you really need to have gets done first. Creating breathing room, things that we've already talked about. Room to make mistakes, time to make mistakes, time to learn so that you can do things, you can do things differently. You're not dependent on having it be perfect the first time. Setting expectations, go, no-go criteria. These are all things that we've looked at before. One of the things yes, then we have the question of the team. Now let's say we've got a lot of people in this room. I would say that we